Hello, everyone. Welcome back. Today, I'm going to be talking about using rates of change to create a graph. Okay, so let's just do a quick review here on drawing appropriate distance time graphs and speed time graphs for the following situations. So, a car coming to a stop at a red light. Well, in that case, first, they're going to be traveling a faster distance for their speed, then they're going to slow down until eventually they're going to stop. As for the speed versus time, their speed is going to be fast at first, right? And then their speed is going to slow down until their speed at some point is at zero. Their speed at some point is going to be zero because they've come to a stop. B says a car accelerating away from you. So that would be a car accelerating. So their distance is going to get more and more and more for the times because they're accelerating away. And their speed versus time is also going to do something similar, right? Their speed, they're going to speed up, starting at a slower speed for the time, then going up to a faster speed, right? They're going to go up to a faster speed with respect to the time because they're accelerating away, right? And same with their distance. As they're accelerating away and their speed speeds up, the distance they cover is also more, right? They're covering more distance in the same time if they're speeding away. C says a car moving at the speed limit. So the speed limit says very specific speed. So therefore, they're just traveling at a constant rate the entire time. So the distance versus time would be a straight line. And then the speed versus time, where they're just going to, whatever the speed limit is, let's say this is the speed limit, they're just going to travel at the speed limit. Their speed stays the same the entire time. They're not slowing down, they're not speeding up in this time, they're just staying put in terms of speed. And then D says a car waiting for a light to turn green. So if they're waiting for a light to turn green, that means right now the light's red and the car is stopped. So they're not going any distance. So they're maybe, let's say they started here. They're not going any distance. Time is passing and the distance is constant. And then as for the speed, their speed is nothing, right? So their speed is not just a constant speed, as we saw in letter C, but their speed is actually zero. So it would be this line here where time is passing but they're not going at all until the light turns green. And it doesn't say that in D. It just says that D is just the point of time when the car is waiting for the light to turn green before it actually does turn green. Good. Awesome. Then it says match the following types of growth curves. So here we have A is decreasing at a non-constant rate. So rapidly initially. So rapidly decreasing initially and then just decreasing. So I would say that one best goes to this graph here, right? Because at first it's rapidly decreasing initially and then slowing down, but it's always decreasing. It's just, decreasing at a lower rate later on. B says no growth. So that would, of course, be this one here, right? Because there's no growth or anything. It's just, a flat line. Then we have increasing at a non constant rate, so rapidly initially. So increasing at a faster rate initially and then a slower rate later on. So that would be this one here. Then we have increasing at a constant rate. So that would be straight line going up, right? Increasing at a constant rate. Then we have, let's see. Then we have E, which is decreasing at a constant rate. So that would be this one, right? Because it's decreasing, but it's decreasing in a straight line, so constant rate. And then F is decreasing at a non constant rate, but decreasing slowly initially and then faster. So that would be this one here. Because at first it's slowly decreasing and then the slope, plummets and goes even further down, a much steeper slope after that. And then G must be this one, which is increasing at a non constant rate. So initially going slow and then, skyrocketing up, later going faster. Good. Okay, so I hope that review helped. Yeah, this was just I'm hoping this made a lot of sense. If it didn't, please do come see me during office hours because this stuff is important for this course, but it is also review from previous courses. The new stuff is going to be coming in example 3, so let's talk about that. So, example 3 says John is training for a marathon. His training run includes beginning at a constant cruising speed along a flat road at 15 kilometers per hour for 1.5 hours. He slows down as he climbs a hill of 2 kilometers for 30 minutes. At the top of a hill, he speeds back up to his constant cruising speed on a flat road for another 10 kilometers. Then he accelerates down a hill of 4 kilometers for 15 minutes. Then he immediately comes to another hill and coasts to a stop to drink water and rest for 30 minutes. Sketch a graph, a distance time graph, and calculate John's average rate of speed for each section of his run. Sketch an average speed time graph. Okay, so that's a lot. That's a lot of steps. So let's kind of go one step at a time when we have a really big kind of question like this. So first things first, let's figure out our distance and our time. So let's do here for distance 1, 2, 3, 4. Let's do 10, 20, and 30. And then here, let's do 1, 2, 3, and 4. Okay, because his total distance is 32. So yeah, so that will work. Okay. And they want to do an average speed versus time graph as well, but let's not worry about that yet. Let's start with distance. So the first thing it says, his run includes beginning at a constant cruising speed, flat along a flat road of 15 kilometers for 1.5 hours. So that means that he traveled at a constant rate and he got to 15 kilometers after an hour and a half. So an hour and a half is right here, and 15 kilometers is right here. And I should mention this is kilometers and this is time in hours. So let's mention that. So that's our first one, and it's a constant rate. And because it's a constant rate, we just draw a straight line for a constant rate. So simple as that. Okay, so that's the first part of his run. And what's his average rate of change for part 1 of his run? That's going to be 10 kilometers per hour, right? Because it says that he's along a flat road, 15 kilometers for 1.5 hours. So 15 kilometers over 1.5 hours is equal to 10 kilometers per hour. So that's his average rate of change for that part of his run. Next, it says he slows down as he climbs a hill of 2 kilometers for 30 minutes. So that means that it for 2 kilometers, it took him 30 minutes, which is half an hour. So that means that's 4 kilometers per hour was his speed for that part of it. Right? So for this part, he's slowing down. He's slowing down his speed for the next half an hour. So let's draw that part where he slows down his speed for a half an hour. Then it says at the top of the hill, do I skip anything? No, okay. At the top of the hill, he speeds back up, back to his constant rate for another 10 kilometers. Okay, so his constant rate was 10 kilometers per hour, so we can just copy that from above. So that there's his constant rate, and he's going to do that for another how many kilometers? 10 kilometers. Okay, so right now we're right there. We need to go up to another 10 kilometers. And that's for how long? It didn't tell us, but that's okay. We know the rate, and so we can figure out how long that's for. That's going to get us to 3 hours, which makes sense because if we're going 10 kilometers an hour and we're doing that for 10 kilometers, it's going to take an hour, right? So it didn't actually tell us explicitly how much time that would take, but we know that he's going 10 kilometers and he's doing that at a rate of 10 kilometers per hour. So it must take 1 hour to travel 10 kilometers. So that makes good sense. Then he accelerates down the hill 4 kilometers for 15 minutes. Okay, so that means that he's going another 4 kilometers in 15 minutes. So that's going to be at a rate of 16 kilometers per hour that he's going to speed up. So he's speeding up for just 15 minutes. And then it says he immediately then comes to another hill and coast to stop and take a drink of water and rest for 30 minutes. So for the next 30 minutes he rests and he doesn't go any speed at all. So for that part, of course, he's going 0 kilometers per hour. Good. Okay. So there we go. So next, let's draw his average speed. His average speed for the different times. So the highest average speed was 16. So let's see if we do 5, 10, 15, 20, 25, 30. Let's actually do, can we do 1 unit per thing? Maybe actually. Yeah, we could do 1 unit for each thing. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh no, that's not going to work. That'll just get us to 13. We need to get up to 16. So we'll do by twos. So I choose 2, 4, 6, 8, 10, 12, 14, 16. So there we go. I feel like we're not really utilizing all the space, but if we do 1 for each, then it's not really going to work. We could do halves for each unit, but that kind of gets complicated, so I don't like to do that. Okay, so then let's do 1 hour, 2 hours, 3 hours, 4 hours, like that. And let's continue. So the average speed for the first hour and a half of the run was 10. So let's put that in, that it's 10. Oh no, that's 2 hours. We just need first hour and a half. So right up to there, it's 10. After that, it goes down to 4 kilometers per hour for the next half an hour. So let's go down to 4 for the next half an hour. Then it goes back to 10 until from hour 2 to hour 3. And then it goes to 16 for 15 minutes. And then it goes to 0 from 3 hours 15 minutes to 3 hours and 45 minutes. So down to there. And there we go. We're all done. All right, well, good work today, everyone, and I will see everyone for our last lesson of this unit, where we're going to be talking about proving minimum and maximum values using rates of change. Good work today, everyone, and we will see you then. Bye, everyone.